Welcome to the world of coal. This presentation will talk about the formation of coal, how we go about mining coal, and then ultimately how coal is used in everyday life. Hopefully this gives you an insight into the everyday life of a coal miner, both in an underground mine and open cut mine. I hope you find it interesting and exciting.
Located just north of Emerald in the Peak Downs Shire are two quite different coal mines, Gregory and Crinum, and both are contributing to the economy of the Emerald region. Gregory is an open-cut coal mine that produces around 1.25 million tonnes of both thermal and coking coal every year. As an open-cut mine, Gregory uses truck and excavator fleets and a drag line to strip the soil from the earth in layers to uncover the coal. However, Crinum is an underground coal mine that extracts around 4.25 million tonnes of thermal and coking coal annually. Both Gregory and Crinum coal mines are owned by the BHP Billiton Mitsubishi Alliance, which owns many coal resources throughout central Queensland, including the Blackwater, Norwich Park, Saraji, Peak Downs, Goonyella Riverside and South Walker coal mines, plus the Hay Point coal terminal. Every time you turn on the light, you're using coal. Why? Because thermal coal is used in power stations to generate electricity. When you go home after school, have a good look at your family's car. And when you eat a meal tonight, look at your knives and forks. And when you feed your dog or cat, have a look at the can that the food comes in. Why? Because they're all made of steel, and you can't make steel if you don't have coking coal. Every day, you're likely to use something that is made partly of coal, or coal was used to make it, and this also includes soaps and cosmetics, plastic, rubber and ceramic tiles. Coal is called a fossil fuel because its energy was captured in prehistoric times. Gregory Crinum mined the Lilyvale coal seam that was formed about 260 million years ago during a geological period called the Permian. During the Permian period, Gregory Crinum coal mine was a broad flat area in the upper flanks of the delta or mouth of an ancient river. This river emptied out to sea somewhere around where the town of Duringa is located now. The ground level in the upper delta was about the same as the water level of the river, so a swamp environment was created. The plants that grew in this swamp dropped a large amount of leaves, branches and seeds into the swamp waters as part of their natural cycle of growth and decay. Over many thousands of years, the swamp environment transformed this decaying plant material into a soft, spongy material called peat. If the peat in the swamp remained uncovered, it finished decaying and oxidized. However, sometimes a great amount of rain fell, and silt, small rocks and mud from the upper reaches of the river were washed down and dumped in the delta, deeply burying and compacting the peat underground. Or eruptions from volcanoes many years ago would bury the peat under layers of ash. Whenever the peat level became buried by flooding or by ash, the swamp and plant life would re-establish itself on the new surface and begin the process of creating peat again. At the same time as this cycle was happening on the surface, deep underground, the Earth's geothermal heat was working on the compacted peat to drive off the water and other volatiles like hydrogen, nitrogen and oxygen. This heat gradually matured the peat into hard chunks of carbon material that we now know as coal. The cycle of the swamp creating peat that became buried and then transformed into coal happened again and again and again in the upper reaches of the delta throughout the Permian period. The layers of coal formed between rocks created a coal seam that came to be known as Lilyvale. Scientists have measured the accumulation rate of modern-day peats, and using this information have estimated that it would have taken about 300,000 years to accumulate enough peat to form the Lilyvale seam. So how do we know where to find coal when all of this happened millions of years ago? Although coal is developed in flat horizontal layers, these layers are often deformed by tectonic movements in the Earth's crust that result in folding, faulting and tilting of the coal seam. Uplift of the coal seam, combined with erosion, can result in coal seams that were once deeply buried being pushed upwards until it becomes exposed on the surface. Ludwig Leichhardt was the first person to discover coal in the Bowen Basin when he found a surface outcrop in a creek bed near Blackwater in 1878. Mining geologists looking for coal always begin their search in these ancient sedimentary basins because they know that these are the environments where coal is formed. The geologists do walk along watercourses looking for surface outcrops, or they use drills that can reveal coal hundreds of metres below the Earth's surface. When geologists discover coal, they need to drill through the Earth in a number of places to find out how thick, how long and how continuous the coal seam is. Then, samples of the coal area are taken to laboratories for further testing and chemical analysis. One of the most important tests is to find out the ash content of the coal. Customers who buy thermal coal need an ash content of below 25%, while customers of coking coal need an ash content below 12%. If the ash content is higher than 25, then it might not be economically worthwhile to mine because it would be hard to find customers who wish to buy the coal. So the geologists have discovered a seam of coal with a suitable ash content. What next? Setting up a new coal mine costs a lot, so a company has to make sure that they can make enough money from selling the coal to cover the cost of building the mine and removing the coal from the ground. This adding and subtracting exercise is called a feasibility study. Mining companies then need to get independent scientists and engineers to put together a mine impact assessment study before the Queensland Government can decide if the company is allowed to build the mine. An impact assessment study is really a number of different studies by different experts who try to find out how the plants, trees, animals and people will be affected if a mine is built close to their home. Often these studies show that a mine will be good for people because they create good jobs and help businesses do well in the towns. However, sometimes these studies show the mine will affect an endangered species habitat. If this happens, then the company may have to plant trees and create another habitat for that animal, or relocate all those animals to a similar habitat in a similar area before the mine can be built. Before we start to look at how coal is mined, we need to talk about safety, because safety is the #1 concern of all mines. Great efforts are made by Gregory Crinum to ensure that every mine worker, contractor or visitor to Gregory Crinum is made as safe as possible when on site. That's why everybody who comes onto a mine site must wear personal protective equipment called PPE. Some examples of PPE that everyone on a mine site must wear are steel-capped boots, hard hats and safety glasses. Mine workers must also wear clothing with a reflective strip that makes them easy to see when they're working at night and underground. Other different types of PPE are worn when mine employees are doing certain jobs. Some examples are wearing dust masks when in dusty areas, or gloves and face shields when welding. As well as wearing the right PPE, the mines employ a permanent ambulance officer and have at least one first aid officer on every shift. They place safety tags on equipment that may be faulty and cause harm to a person, build safety rails to stop people falling from heights, use trolleys, hoists and cranes to lift heavy equipment, and work together to write up step-by-step instructions called procedures that let mine workers know the safest way to do many of the jobs that need to be done on site. Some employees join the mine's rescue team and receive special training to prepare them to respond to any emergency. Now that you know how important safety is on mine sites, let's see how coal is mined at Gregory. Because the Lilyvale coal seam is less than 60 metres from the surface, Gregory uses a mining technique called open cut. The first step in open cut mining is to remove all the topsoil using dozers and trucks. This topsoil is stockpiled for later rehabilitation of the mined area. The next step is to loosen the overlying rock by blasting. The explosive used in blasting is called ANFO, which stands for ammonium nitrate and fuel oil. Holes are drilled about every 10 metres in a pattern and loaded with up to 3 tonnes of ANFO. The rock covering the coal that is loosened by the blasting is called overburden. The overburden is taken off the coal by enormous electrically powered drag lines that have buckets that can make a hole the size of a backyard swimming pool with just one scoop. A dragline weighs about 2,500 tonnes, is as high as a 4-storey block of flats and has a boom as long as a football field. A dragline sits on a big round tub which allows it to swing and pick the overburden up and then place it onto a large stockpile that is called a spoil heap. When the dragline has taken all the overburden away, the coal is taken away using diesel excavators that place the coal onto haul trucks that are capable of carrying 80 tonnes of coal. These trucks carry the coal to the dump station, where it is tipped out, ready to be sized, sorted and washed by the coal preparation plant. The machinery that is used in open cut mining is very expensive. One bulldozer can cost about $2.5 million, and Gregory's dragline cost $60 million to replace. With almost 60 pieces of mobile equipment at Gregory Mine, and about 1,000 pieces of equipment used in the coal preparation plant, Gregory Mine needs many electricians, fitters and boilermakers in its maintenance department to make sure that all this equipment is kept running and in good repair. Keeping the machinery running at a mine site is very important. One breakdown can cost the mine thousands of dollars in lost production for every hour that it is getting repaired. Lost production is the amount of coal that could have been mined and sold if that particular piece of equipment had not broken down. Being able to get access to the right spare part is very important if a machine is to be fixed in the shortest possible time. The warehouse at Gregory Mine will often keep a stock of some spare parts ready in case of breakdowns. Other spare parts can be bought from machinery dealers that have set up their business in Emerald to supply the coal mines like Gregory Crinum. To keep the number of problems with machinery to the lowest level, Maintenance Department will work with the mining and coal preparation plant to find the best time for machinery to be taken out of production for servicing. The Maintenance Department will also schedule routine overhauls of equipment to stop breakdowns happening in the first place. For example, the tracks and blades of a D11 bulldozer are replaced every year, and every 4 years the engine and transmission will be replaced. The machinery and equipment that is used on mine sites is often very large and very heavy, so the right equipment needs to be used to lift it before it can be worked on. Even a tyre change can provide many challenges for the tyre fitters at Gregory Mine. The Lilyvale coal seam is tilted further than 60 metres below the surface at Crinum, so an underground mining technique is needed to remove the coal. The technique used at Crinum is called longwall mining. In order to start longwall mining, we must first develop tunnels around the block of coal that needs to be mined with the longwall. A machine called a continuous miner is used to prepare the tunnels or roadways needed for longwall mining. The continuous miner cuts coal mechanically by using a long rotating drum which has picks around the outside. Coal is thrown out of the back of the continuous miner and into a shuttle car. The shuttle car takes the coal from the continuous miner and loads it onto the conveyor, which takes it to the surface. Two tunnels about 2,000 metres long and 270 metres apart are made by the continuous miner. These tunnels are joined together by a third tunnel. The long wall is installed into the third tunnel and mines the block of coal in between the two longer tunnels. The third tunnel marks the spot where longwall mining begins. A machine called a shearer, which is operated by remote control, is used to remove the coal. The shearer has two large rotating drums covered in picks on each end and runs back and forwards along the 270 metre coal face and deposits the coal onto an armoured face conveyor. This conveyor takes the coal away from the coal face, through crushers and onto other conveyors that take the coal to the surface. To make the tunnel safe, large hydraulic jacks, called shields, are used to support the roof where coal is to be mined. As the shearer moves across the face, the shields are advanced behind it, and the unsupported roof behind the shields is allowed to cave in and fill the hole behind. The shearer keeps mining coal, strip by strip, until the longwall has travelled 2,000 metres along the tunnels. The longwall is then taken apart and transported to the beginning of a new block and put back together so it can start all over again. Crinum's raw coal is transported to Gregory Mine's coal preparation plant by conveyor. The conveyor is 10 kilometres long and capable of carrying an average of 1,000 tonnes of coal per hour. The maintenance department at Crinum Mine needs to work with very specialised machinery that just can't be found in any other workplace. Many pieces of equipment needed for underground mining can't be bought at shops or from manufacturers, so the maintenance department needs to modify or change standard machines so they can be used underground. All machinery, modified or not, has to be thoroughly checked by government safety experts and certified as safe before it can be used underground. The Crinum Maintenance Department is responsible for keeping about 40 mobile diesel vehicles and up to 8 conveyor drive heads up to 3 kilometres long in good order. Underground mining equipment is just as expensive as the machinery used in open cut mining. A conveyor costs $2.5 million to buy, with another $1 million needed to install it. One modified light vehicle can cost around $200,000. The tradespeople at Crinum also have responsibility for installing and repairing the real-time gas monitoring system, which is responsible for warning people working underground if gas is released during mining. Repairing equipment underground brings with it a number of special challenges for the Crinum tradespeople. One challenge comes from the gas that can sometimes be found with coal. The possibility of a spark igniting this gas and creating a fire means that everything electrical needs to be enclosed in special flame-proof equipment. Even the headlights of vehicles need to be enclosed. Electrical equipment switchgear are enclosed in special thick cabinets that are designed to quench any heat. Another challenge is the hot, humid and dusty conditions underground. These conditions mean that equipment needs to be serviced and maintained more often. It also means that tradespeople who need to go underground to repair machines that have broken down need to work in conditions that are a lot less comfortable than working on the surface. However, it's more than uncomfortable conditions that create a challenge for tradespeople going underground. Due to limited space, large cranes cannot be used to lift up a very large and heavy piece of equipment. We've seen coal mined by the open cut mining method at Gregory Mine and by the longwall underground mining technique at Crinum. The last time we saw the coal that was mined at Gregory was when it was tipped over the dump station. The last time we saw the coal mined at Crinum, it was taking a ride over to Gregory on that long conveyor belt. So, what's next? When coal comes from the mine, it is in different sized pieces and is mixed in with other minerals that won't burn. The coal needs to be crushed, screened for size and washed at the Gregory Coal Preparation Plant before it can be sold. Outside the Gregory Coal Preparation Plant, or CPP as it's called from now on, the coal from Gregory and Crinum is dumped onto a sizing screen that sorts out the larger rocks that need to be fed into a rotary breaker before being placed on the main stockpiles. Both the Gregory and the Crinum stockpiles sit above an underground tunnel called a hopper that feeds the coal through a system of conveyor belts and surge bins into the CPP. Once inside the plant, the coal goes through a desliming screen that divides the small coal from the larger coal. Large and small coal go through two separate processes at the CPP. Large coal is taken through a process called heavy density medium separation. Large coal, water and magnetite are mixed together to form a slurry. The slurry is then pumped into a machine called a heavy medium cyclone that creates a whirlpool effect, forcing the lighter material in the slurry to sit in the centre of the whirlpool while the heavier material is forced to the outside. The first time the slurry is put through the heavy medium cyclone, the more commercially valuable and lighter coking coal is forced to the centre and taken out. The next time thermal coal is forced apart from the heavier rocks and separated. The coking coal and the thermal coal are then taken separately to a rinsing screen that washes the magnetite off the coal before being placed in a machine called a centrifuge. The centrifuge spins every drop of water off the coal. After being dewatered by the centrifuge, the thermal and the coking coal are then taken by conveyors to their separate stockpiles, ready for their next part of their journey. Meanwhile, the small coal is undergoing a CPP process called flotation that separates the coal particles from the slimes. Because flotation takes place in a water tank, the slimes firstly need to be coated with diesel to stop it from repelling water as coal normally would in its natural state. The diesel-coated slimes are then placed in the flotation tank that has been injected with air bubbles and a chemical called MIBC. The chemical MIBC attracts both the coal particles and the air bubbles, allowing the mixture to float to the surface of the tank, while the sandy, clay mixtures that used to cling to the coal sink to the bottom. The froth of coal particles, MIBC and air bubbles is then skimmed off the top of the flotation tank by paddles that then feed the mixture into a dewatering machine. The coal is then taken to their separate stockpiles to await transportation. Environmental management and the reuse and recovery of chemical and minerals used in the coal preparation plant is very important. The CPP has machinery and processes that deals with water recovery, magnetite recovery and reject disposal. The stockpiles of thermal and coking coal are loaded onto electric trains both day and night. Operators are assisted by a computer using a system called Process Logical Controllers. Once loaded, the coal is transported direct to customers in Queensland or taken to the coastal ports of Hay Point or Gladstone for export. When the coal arrives, it is emptied automatically from the rail wagons and placed in large piles by machines called stacker reclaimers until the next cargo ship arrives. When the ship arrives, the coal is taken from the stockpiles and loaded into the huge storage compartments of the ship. From there, the coal begins its long journey to its new owners in countries all over the world. Mining companies are only temporary users of the land that they mine, so it's important that the land disturbed by open cut and underground mines is able to be used once again when mining is finished. Open cut mining disturbs the land to a much greater degree than underground mining because the layers of soil are not taken off and mixed up. Underground mining drops the surface level of soil down a couple of metres over the areas where the longwall has mined the coal. This dropping of the layer is called subsidence. Subsidence is easier to spot when it crosses roads or other structures. At Gregory Open Cut Mine, the dragline leaves a series of steep ridges and valleys called spoil piles. The first step in rehabilitation is to level these piles into rolling hills by a bulldozer and then cover them with the topsoil that was collected at the beginning of open-cut mining. A dozer with a big seeder attached behind it is then used to drop seeds and fertilizers onto the new hills. Over time, these seeds eventually grow into grasses and trees. Throughout the mine site, you will see land that varies from having been recently rehabilitated right through to areas that contain 2 to 3 year old growth to areas which contain well-established trees. The Environmental Department at Gregory Crinum have other responsibilities as well as rehabilitation. Some of these include keeping weeds and pests under control, making sure that the quality of surrounding waterways and underground water aquifers is not affected by mining, and helping the mine practice sensible waste management and recycling practices. We have followed coal from when it began in prehistoric times through to how it is discovered, mined, washed and transported and then used every day by you and me in lots of different ways. Coal mining is one of the most important industries in Australia. Taxes paid by the coal mining industry to the state and federal governments are given back to the community in the form of hospitals, schools, roads and libraries. Coal mining also directly employs over 250,000 people as miners, accountants, health and safety officers, engineers, human resource officers, drillers, administration assistants, environmental officers and managers. The industry spends over $1 billion a year buying and repairing mining equipment and buying goods and services such as accommodation, hire cars and training that means more businesses can employ more people. This creation of jobs outside of mines is called indirect employment, and it's estimated that 1 in 4 people in the Central Highlands are employed because of the presence of mines in the region. Coal mines also help the local community through donations and sponsorship of schools, community and sporting groups. In one way or another, everyone benefits from coal mining.